start our video. The most important topic, benzene. Uh, we study in the plus two. It is important in board exam. 5 to 6 marks question is asked from this chapter. Let's start our chapter. Aromatic hydrocarbons. First of all, here it is also known as arenes. यसलाई एरेन्स पनि भनिन्छ हैन. बेन्जोइड रिङ एरोमेटिक हुन्छ, यो हामीलाई थाहा भएकै कुरो हो. र बेन्जिनलाई यसलाई हामीलाई यसको क्यारेक्टरिस्टिकमा हामीले हेर्न सक्छौँ. यो साइक्लिक हुन्छ अनि यसको मेम्बर रिङहरू चाहिँ 5 छ 7 अनि फ्ल्याट स्ट्रक्चरमा हुन्छ. अनि यसमा चाहिँ हामीले एडिसनल रियाक्सनहरू एड गर्न सक्छौँ. यसमा हाई पर्सेन्टेज अफ कार्बन हुन्छ अनि यसलाई हामीले बन्ड चाहिँ इजिली सफ्टली सुटी फ्लेमले बम हुन्छ यो. देन Huckel's law for aromatic rings. Most important topics. It used in the benzene rings to find the pi electrons. Here in this benzene contain 3 pi bonds, that is 3 into 2, 6 pi electrons, which follows the 4n plus 2, which is known as Huckel's rule. For it mostly used for the in benzene to find the pi electrons. Naphthalene and anthracene, also known as naphthalene, contain 5 pi bonds. 5 into 2 is equal to 10 pi electrons. And anthracene contains 7 pi bonds, that is 7 into 2 is equal to 14 pi electrons. It also follows the Huckel's law. Here you see in the figure naphthalenes. You count here 1, 2, 3, 4, 5, 6, 7. Naphthalene 5 pi bonds and anthracene 7 pi bonds. Multiplies by 2 is equal to 5 into 2 10 naphthalene pi electrons, and anthracene 7 into 2 is equal to 14 pi electrons. It is easy for you use formula. डबल बोन्ड्समा चाहिँ हामीले के गर्छ भन्दा कार्बनमा 1 बोन्ड इज सिङमा हुन्छ, another bond is pi हुन्छ. Benzene, we know the formula of benzene C6H6. Structural molecular formula is here shown in the figure. For the preparation of the benzene, we have many methods, but in practice, in our syllabus, first method is decarboxylation. Decarboxylation means when sodium benzoate is heated with the soda lime NaOH plus CaO in the presence, benzene forms. Here in the figure, we see the sodium benzoate structure. Here in benzene, first of all we draw the benzene structure. In the attached we CONA plus addition of the NaOH. In the presence of the calcium oxide and the heat, we get the benzene and leaving group Na2CO3. First method. We also get the benzene from the phenol. When phenol is heated with zinc dust, benzene is formed. Here you know the phenol, the molecular structure of phenol is phenol. In the attached we found OH. Addition of the zinc in the presence of heat, we get the benzene along the zinc oxide in the leaving group. We also get the benzene from the chlorobenzene by reduction process. We first of all know the chlorobenzene structure. Here you see the chlorobenzene structure. On the addition of NaCN hydrogen in the presence of NiAl, NaOH, we get the benzene plus additional remaining groups HCl. From ethine also we get the benzene. You see in the figure. First we know the ethine molecular structure and for molecular formula. Molecular formula we know, or structure formula is shown here. In the presence of the organoanacatalyst, heating 70 degrees Celsius pressure, we get the benzene. Properties of benzene, we know it is a colorless liquid, so insoluble in water. When benzene addition reaction, here you know when benzene is added to the hydrogen, in the presence of nickel and 200 degrees Celsius by temperature, we get the cyclohexane C6, which molecular formula is C6H12. Another way, from chlorine, when benzene is added to the chlorine in the presence of UV light, we get the benzene hexachloride BSC, which molecular formula is C6H6Cl6. Here we find in the benzene in the outermost structure 4 of 1 2 3 4 5 6 6 there is chlorine attached. Addition of ozone lysis is the most important topic for which in the exam also it comes. You must not lips, you must read this topic, ozone lysis. ओजनको लागि चाहिँ हामीले जब बेन्जिन फर्म गर्नको लागि चाहिँ ट्राइओजोनो विथ when boiled using dust and water gives क्लाइओक्जाइल. बेन्जिनमा चाहिँ हामीले बेन्जिनमा चाहिँ हाम्रो छ साइडमा चाहिँ हाम्रो हाइड्रोजन एट्याच हुन्छ हैन. त्यसैले चाहिँ हामीले ओजोनमा इन द प्रेजेन्स अफ ओजन एड गर्यौँ भने चाहिँ हामीले बेन्जिन ट्राइओक्जाइड पाउँछौँ र त्यसलाई चाहिँ Z10H2O मा बोइल गर्यौँ भने CHO पाउँछौँ र CHO लाई प्लस एडिसन अफ वाटर H2O2 हाइड्रोजन पेरोक्साइड एड गर्यौँ भने हामीले ग्लाइकोक्जल पाउँछौँ. यही नै यसको मेन इम्पोर्टेन्ट टपिक हो. मेन हामीले बुझ्नुपर्ने नलेज नै यही हो. यति बुझ्नुभयो भने तपाईँले चाहिँ आफ्नो इक्जाममा लेख्न सक्नुहुन्छ. त्यसै गरी 8औं टपिकमा छ इलेक्ट्रोफिलिक सब्स्टिट्युसन रियाक्सन. सब्स्टिट्युसन रियाक्सन भनेपछि इलेक्ट्रोन मिन्स इलेक्ट्रोन लभिङ वी नो. In the benzene electrons, here we get substitution of hydrogen atom from benzene by electrophiles. We get the electrophilic electron lobbying easily. Nitration another topic, substitution of hydrogen atom by NO2 nitro groups. Nitrate mix is a mixture of con HNO3 and con H2SO4. Another topic, sulfonation. Nitrobenzene, it is also most important topic. In your exam, it also asked. Must you know this molecular formula and its process. Sulfonation, sulfonic acid group SO3H+. It also carried out by treating of fuming sulfuric acid con H2SO4 with saturate SO3. Further we get benzene sulfonic acid. First of all we have to prepare SO3 H plus and leaving group HSO4 from SO3 plus H2SO4 conc. Halogenation, substitution H atom by halogen atoms is known as halogenation. Chlorination means carried out by the treating with Cl2 in the presence of FeCl3. Bromination carried out by treating with Br2 in the presence of FeBr2. Here in the figure, molecular formula and figure you see here from the benzene plus chlorine in the presence of FeCl3 chlorobenzene. Likewise, benzene plus Br2 in the presence of FeBr3 we get bromobenzene plus in the addition leaving group H plus. Alkylation and acylation. Alkyl means Rn, acyl means RCO groups respectively. Federal clap alkylation, substitution of H atom by alkyl atom. We have to substitute H atoms from benzene and it has in this we have first required benzene and we add the chloromethane and from the benzene H atom is substituted and it goes to leaving group and from the chloromethane CH3 is attached to the one side of the benzene. In the final product we get the methyl benzene which is known as toluene. Most important topic you must remember it. यसमा केही त्यस्तो केही छैन. बेन्जिनलाई चाहिँ हामीले क्लोरोमिथेनसँग एडिसन गर्छौं र इन द प्रेजेन्स अफ एनहाइड्रस AlCl3 र यसमा भएको चाहिँ ClCH3 चाहिँ हाम्रो त्योबाट चाहिँ हाम्रो CH3 चाहिँ बेन्जिनको एउटा साइडमा आएर एट्याच हुन्छ र त्योबाट चाहिँ हाम्रो H एटम चाहिँ हाम्रो रिमुभ हुन्छ, एच एटम चाहिँ रिमुभ हुन्छ र त्यो बचेको क्लोरोमिथेनबाट सिएल र उताबाट एच आएको बेन्जिन चाहिँ त्यो एडिसन फर द लिभिङ ग्रुपमा चाहिँ एचसिएल बाई प्रोडक्ट फर्म हुन्छ। लाइकवाइज फ्रेडर क्ल्याप एसाइलेसन, यसमा चाहिँ सिओ ग्रुप हुन्छ, आरसिओ ग्रुप र बेन्जिन त हाम्रो चाहिने नै भयो। यसमा चाहिँ यसको आरसिओ ग्रुपमा चाहिँ हामीले के लियौँ भन्दाखेरि इथानोसाइक्लोराइड इन द प्रेजेन्स अफ एनहाइड्रस AlCl3। यसमा चाहिँ त्यही हो, तपाईँको बेन्जिनबाट एच रिमुभ हुन्छ र उताको फङ्सनल ग्रुप चाहिँ सी र डबल बोन ओ र CH3 चाहिँ बेन्जिनमा आएर एट्याच हुन्छ र त्यो बचेको एच र बेन्जिनको बचेको एच र उताबाट बचेको सिएल चाहिँ बाई प्रोडक्टमा HCl फर्म हुन्छ। कन्भर्सन मिन्स बन्स हो इज एज यु नो। बेन्जिनलाई चाहिँ अक्सिजनमा एडिसन गऱ्यो भने चाहिँ हामीले के हुन्छ भन्दाखेरि कार्बन डाइअक्साइड प्लस H2O पाउँछौँ, सुटी फेम टाइपको हुन्छ यो। ओरिएन्टेसन अफ बेन्जिन डेरिभेटिभ्स इन द फियर यु नो हियर in the there are three, we know ortho, meta and para. Here we read पोजिसन अफ आर्टिकल अर्थो ओ को अर्थो भन्छौँ र मेटालाई म्याम भन्छौँ र पारालाई पी भन्छौँ। यो हाम्रो जेनरल सिमुलाइज फर्मुला भयो। एटम अफ ग्रुप अफ एटम अलरेडी प्रेजेन्ट इन द बेन्जिन रिङ विच डाइरेक्ट्स द इनकमिङ इलेक्ट्रोड टुवार्ड अर्थो एन्ड पारा पोजिसन आर्टिकल अर्थो पारा डाइरेक्टर। इलेक्ट्रोफाइल चाहिँ हाम्रो अर्थो र पारा पोजिसनमा जान्छ। Here in the figure you see atom of group of atoms of atom with lone pair of electron of atom which is bonded to the carbon atom of benzene ring are ortho para director. For example, here OH, OR, NH2, NHR, Cl, Br, iodine, etc. In the attach of benzene ring OH, we get the it is attached on the ortho para director. Generally, like in group of atom already present in the benzene ring which direct the incoming electrophile toward the meta position are called meta directors. Here you see in the molecular structure some important question which also asked in the board exam of +2. Here, how to make a chlorines from the benzene. फर्स्ट अफ यहाँ यो यसमा के दिन्छ भन्दाखेरि हाम्रो इक्वेसन दिन्छ होइन, प्रायः जसो क्वेसन सोद्धाखेरि र कुनै चाहिँ यस्तो वाट एपेन्स वेन क्लोरोबेन्जिन इज हिटेड इन द प्रेजेन्स अफ लिथियम AlH4 भनेर पनि सोध्नसक्छ। यस्तो प्रायः जसो यस्तै टाइपको क्वेसन सोध्छ। यसमा फर्स्टमा हामीलाई के चाहियो, बेन्जिन टोलेन्स। क्लोरोबेन्जिनलाई के बनाउनु पऱ्यो, बेन्जिन बनाउनु पऱ्यो फर्स्ट स्टेप्स, र बेन्जिनलाई चाहिँ इन द प्रेजेन्स अफ CH3 Cl AlCl3 गऱ्यो भने टोलेन्स पाउँछौँ। लाइकवाइज इन द सेकेन्ड क्वेसन, सोडियम बेन्जोएट इन द प्रेजेन्स अफ हिट NaOH plus CO goes to X product, like in the presence of Cl2 FeCl3 goes to product Y. First of all, you know the molecular formula and the structure of the sodium benzoate. Molecular structure here in the benzene structure, in the one side CON is attached, which is known as sodium benzoate. In the presence of NaOH plus CO in the with heat, we get the benzene. When we get the benzene, it is here like chlorine plus FeCl3, we get the chlorobenzene. Easy. Likewise, third question, phenol. Starting from phenol, how do you obtain cyclohexane? First of all, we know the molecular structure of phenol. Phenol, here you see phenol structure. When phenol is heated in the presence of zinc dust, we get the benzene. After getting benzene, we heat it in the presence of H2 and Ni, we get the cyclohexane. It also most important question. What happens when benzene is heated with acetic anhydride in the presence of anhydrous AlCl3? When benzene is heated with acetic anhydride in presence of anhydrous AlCl3, then acetophenone is formed. Like in the benzene structure, we added the acetic anhydride. In the presence of anhydrous AlCl3, we get the acetophenone process in the addition by a living product CH3COH. Likewise, 5 number question. Why is benzene called the aromatic according to the Huckel's rule? Because it follows the Huckel rules. From Huckel's we find the pi electron. How many of pi electrons are present in the benzene rings? Here benzene contains 3 pi bonds, that is 3 into 6 is equal to 6 pi electrons, which declares the benzene rings is according to the Huckel's formula, Huckel's rule, that is 4n plus 2. So it is called the aromatic according to the rules. It is generally used to find the pi bonds and pi electrons. How can we convert ethine to nitrobenzene? Here first we know the structure formula of ethine. Here CS triple bond CS in the presence of organoanacatalysts with 70 degrees Celsius, we get the benzene. If we get the benzene, then we easily get the nitrobenzene in the presence of the Kong HNO3 and Kong H2SO4. With by supplying heat up above 60 degree, we get nitrobenzene. This much from in this video. If you like this video, please like and tell comments what can I improve in the upcoming videos. Thank you for listening. Thank you. If you get